For this section, we're going to learn about graphing rational functions. So we learned about finding the different aspects of a rational function, and now we're going to learn how to put that on a graph. So how do we graph this function? Our first step is to find all holes, asymptotes, and intercepts. And so if you forget how to do this, I would go to your steps notes that we took, and that will tell you how to find all of these things. So our first step is to factor and then cancel. So we have these three different forms of our equation. And from that, you get this information. So I've already gone through found holes, vertical asymptotes, horizontal, x-intercept, and y-intercept. Um, if you forget how to find these, I would reference your step-by-step notes, and you will see that these are the answers that you get. So now, how do we put this information on a graph? So we're just going to go through and draw out what all of these things look like. So a hole is a point, and it's a point in the graph where our graph is undefined. So we are not going to draw it as a closed circle. This is going to be an open circle at the point -1, -1. So on my graph, I go to -1, -1, and I'm just going to draw a little open circle. So my function is somehow going to go through this or on either side of the hole. So that kind of counts as a point on our graph. So for the vertical asymptote, this is at x equals -2. And I'm going to draw this in red. We're going to draw it as a dashed line because keep in mind an asymptote, it's not really part of our function. It's just a line that our function approaches. And it's at -2. So vertical, we're going to draw this up and down at x equals -2, and I'm just drawing it in a different color because it's not part of our actual function. Same thing with the horizontal asymptote at y equals 2. This is now a horizontal line, so we're going to draw it the other way. And I'm drawing it in red because it's not actually part of our function. That's why we use the dotted line and not a solid line. So we don't want to touch or cross these boundaries. Next is our x-intercept, so that is part of the function, so I'm going to use black again. -1/2, 0, so that would be right about there. And then we have the y-intercept at 0, 1/2, which would be about here. So lucky for us, point a little bit better. Okay, there we go. So lucky for us, we have 2 points and a hole on the right side of this vertical asymptote. As you can see, the asymptote splits this graph up into 4 different quadrants. Now, our rational function, when we have one vertical asymptote, is going to have 2 parts. It's going to have a part on the right side and a part on the left side. And we have to determine which side of the horizontal asymptote it's going to be on. Here, we already have some points that are telling us on the right side of the vertical asymptote, our function is going to be below. So what we do is we connect the points and then we draw the rest of the graph going right along that boundary, those boundaries of the asymptotes, just like this. So we're curving toward the asymptote. And your rational function will always have this type of look to it when we have one vertical asymptote. Now we need to figure out, how is the left side looking? Are we going to be up here or are we going to be down here? So to do that, we're going to set up an XY table and plot some points. So we want to pick X values that are to the left of this vertical asymptote now, since we already had points to the right. So let's pick -3, -4, and -5. And what we're going to do now is we're going to plug these into the simplified equation because that's the easiest one to work with to get our y values. So these are the values that you should get when you plug in each x value into the simplified equation. So -3, when we plug that in, we end up getting -5 over -1, which becomes +5. If we plug in -4, we get 7 over 2, which is 3.5. And then if we plug in -5, we get 3. So let's plot those points and we'll see is it going to be above or below our horizontal axis on the left side of our graph? So -3, 5 would be right here. And then we have -4, 3.5. So it's looking like we are above the horizontal axis, and then -5, 3. And you'll see the points start to make what looks like this curve like we have here. So I'm going to connect the points, and just like I did, I'm going to go right along my boundary. So not crossing it, not touching it, but approaching these two lines. And that is how you would graph a rational function.